Okay, we're going to talk now about arc length. So let's say I've got some curve here. A to B, this is C to D. The formula for calculating the arc length is going to be the integral from A to B of the square root of 1 plus dy dx squared. Okay, or we can go along the y-axis, so we'd go from C to D. What's going to change is this is going to be dx y dy. In metric, okay, the arc length is going to be the integral from time 1 to time 2, the square root of dx dt squared plus dy dt squared. So we're going to look at this on something you're familiar with, a line. Okay, we're going to find the length of the curve for x from 1, 4 to 2, 8. So we're just looking at 1 to 2, 4, call that 8. Okay, we're finding the length of this line segment. Okay, so we're going to do this in 3 different ways. We're going to use both of the arc length definitions, and then we're going to use good old-fashioned distance formula. Okay, well, y is 4x, which means dy dx is 4. So dy dx squared is going to be 16. So this is going to be the integral from a to b, which is 1, 2, of the square root of 1 dy dx squared, which is 16. So this is going to be the integral from 1 to 2 of the square root of 17. Well, that's just going to be root 17x evaluated from 2 to 1. Okay, which is just going to be root 17. Okay, we're going to do the same thing here. Okay, d, and this needs to change. This should be dx dy. Okay, so if dy dx is 4, then dx dy is going to be 1/4. So dx dy squared is 1/16. Okay, c and d are the y values. So that's going to be 4 and 8. So this is going to be the integral from 4 to 8 of the square root of 1 plus 1 over 16. This will be the root of, this is 16/16, 17/16. For the integral from 4 to 8 of the square root of 17 over 4. Okay, well that's going to be square root of 17 over 4y, evaluated from 4 to 8. So we have the square root of 17 over 4 times 8 minus 4, which is just 4. So we get root 17. Okay, lastly, good old distance formula. So that's going to be square root of x2 minus x1 squared plus y2 minus y1 squared. So we get 1 squared plus 4 squared, the square root of 1 plus 16, which, drumroll please, is the square root of 17. so now we're going to find the length of the curve, 1 minus x to the 2/3, all of that to the 3/2 from 0 to 1. Okay, so I'm going to start by taking the derivative. So using the power rule, we're going to have 3/2 times 1 minus x squared to the 2/3, subtract 1, so that's going to be to the 1/2. Use our chain rule never goes away. So times a negative 2/3x, subtract 1 from 2/3, we get negative 1/3. Okay, so the 3/2 and the 2/3 cancel each other out. So I'm going to have x, negative x to the 1/3, negative 1/3. Okay, so this is my equation. Now we're going to square it. Okay, so this squared is going to become a positive x to the negative 2/3, because if I take this and raise it to the 2, we'll multiply those. This, if I square it, is just going to get rid of the 1/2. So this is just going to be 1 minus x to the 2/3. Okay, so we'll clean it up and then we'll put it in the formula. So I can distribute this through, so that's going to be x to the negative 2/3. Okay, minus, if I have x to the negative 2/3 times x to the positive 2/3, if I add those exponents together, we get 0, and anything to the 0 is 1. Okay, so now we're going to plug this in the formula. So we have the integral from 0 to 1 of the square root of 1 plus x to the negative 2/3 minus 1. So then we're left with this, which I'm going to go ahead and write as 0 to 1. We have x to the negative 2/3 to the 1/2. So multiplying those exponents together, we get x to the negative 1/3. Okay, so we'll add 1 to the exponent, which will be 2/3. So this will be 3/2 x to the 2/3, evaluated from 0 to 1. Well, this to the 1 is 1, this to the 0 is 0, so this is just going to be 3/2. Okay. So our next one, x equals the integral from 0 to y of square root of secant to the 4th minus 1. So this is x, so we're going to find dx dy. Well, if we're taking the derivative of an integral, the integral just goes away and we replace this for the variable. So it's going to be the square root of secant to the 4th y minus 1. So dx dy squared is going to be secant to the 4th y minus 1. So we're going to have the integral from negative pi over 4 to pi over 4, the square root of 1 plus secant to the 4th y minus 1. Okay. Well, this is gonna pi over 4 to pi over 4. The 1's will cancel, so we're gonna have the square root of secant to the 4th, okay, which is gonna be secant squared. Okay, the integral of secant squared is tangent. Okay, so we're going to have the tangent of pi over 4 minus the tangent of negative pi over 4. Tangent at pi over 4 is 1, minus tangent at negative pi over 4 is negative 1. So we get 2. Here we're going to find a curve through the point 1, 1 whose length is given by this integral. So the integral from 1 to 4 of the square root of 1 plus 4x. The arc length formula is 1 plus dy dx squared dx. So this is equal to dy dx squared. Okay, so if I take the square root of both of these, we're going to have dy dx is equal to 1 over square root of 4 is 2. Well, square root of 1 is 1, square root of 4 is 2, square root of x is square root of x. So we're saying dy dx is equal to 1 over 2 root x, which means y, taking the antiderivative, is the square root of x plus c. That's where this part comes in. 1 equals the square root of 1 plus c. So I subtract 1, so my c in this case is 0. So my final equation is the square root of x. Okay, now we're going to do this parametrically. So we have find the length of the curve defined by y equals cosine t and x equals sine t. So as a reminder, the formula for this is going to be the integral from 0 to pi over 2 of dx dt squared plus dy dt squared. So I'm going to go ahead and do these separately. You could do it in the integral, but I find it easier just to do it separately. So if x is sine of t, then dx dt is cosine of t, which means dx dt squared is cosine squared. dy dt is, or y is cosine of t, so dy dt is negative. Okay, which makes dy dt squared equal to a positive sine squared. So that's what we'll plug into our formula here. So this is now going to be the integral from 0 to pi over 2 of the square root of cosine squared t plus sine squared t. Well, cosine squared plus sine squared is 1. So we're taking the integral of 1, which is just going to be t, and we're going to evaluate that from 0 to pi over 2. So that's going to be pi over 2 minus 0, which is just pi over 2. At time t is greater than 0, the position of a particle is x of t and y of t, where dx dt is t minus 5 cosine t, and dy dt is 6 cosine 1 plus sine t. At time equals 3, the particle is at position negative 1, 2, which really doesn't, we don't really care at this point. Find the total distance traveled from 0 to 3. So that's just going to be the integral from 0 to 3, square root of t minus 5 cosine t squared plus 6 cosine of 1 plus sine of t squared. Okay, which if you just dump that in the calculator is 13.453. Last, we have a multiple choice problem here. So what is the length of this arc from 0 to 3? So start with our derivative. So we'll multiply down 2/3 times 3/2 is 1. So we're going to have x to the 1/2, which means dy dx squared is just x. So we have the integral from 0 to 3 of 1 plus x. This is going to be 2/3 1 plus x to the 3/2. So this will be 2/3 times, when I plug in 3, 4 to the 3/2 minus 2/3, 1 plus 0 is 1 to the 3/2. Okay, so 4 to the 3/2. I always start with the denominator. So we're taking the square root of 4, which is 2, and then cubing it. So this is going to be 2/3 times 8. This is just going to be 2/3. So we have 16/3 minus 2/3, which is 14/3. So that's how you find the arc length of different curves.